Hello, in this video I'll present you about the difference between R and Python codes. R and Python are both powerful languages for data analysis, but they differ in code structure, syntax, and general approach. Just I'll give you some list of points for comparing these two codes. Um, Basically in terms of their difference in structure. The first one is um, primary purpose and syntax. This is the first point of comparison that we have to start with. Um, Originally, R is developed for statistical computing, and R has a syntax focused on data manipulation, statistical analysis, and visualization. The syntax often resembles a language specifically designed for mathematics and statistics, I mean. Whereas Python is a general purpose language, and it is known for its readability and simplicity. Its syntax is more general and intuitive, designed for broader applications beyond data science, for example, for web development and automation. Uh, then the second point is that the data structure. Uh, Data in terms of data structure, R's data structures are mainly statistical in nature. Common structures include vectors, data frames, matrices, and lists. Data frames are especially central to R as they represent tabular data and are the main structure used in data analysis. Whereas Python is just uses more general data structures such as lists, tuples, dictionaries, and sets. For data science, um, the pandas library provides data frames similar to R's, allowing for easier handling of tabular data. Other packages like NumPy provide specialized data structure. Example arrays, for example arrays or optimized for which are optimized for numerical operations. The third point of comparison could be indexing and accessing data. In terms of indexing and accessing, R uses one-based indexing. Um, that is, indexing starts at one, and indexing syntax can vary depending on the data structure. For example, vectors versus data frames. R has unique operators for data just extraction, such as this symbol, dollar symbol, for accessing columns in data frames. We can see, for example, in the following code, data uh, data. Then this is a symbol which is used as equals for defining variables, like what you use a normal equal sign for Python. Then data dot frame, then a equals 1 to 5, b equals 6 to 10. Sorry, I have to correct this. The dot frame. Okay. This. Okay. Then data A, then this one means access column A. Then this one, the dollar sign here indicates that we should access the column A. Data, and this operator to access the first row of column B. Then in Python, it uses zero-based indexing. Indexing starts at zero, sorry, and relies on bracket notation in pandas. Data frames, like accessing data, often involves .ilog for positional indexing or .log for label-based indexing. Let's see the following. For Python, import pandas as PD, and then data equals PD data frame one, two, three, four, five. B, six, 8, 9, 10. Right, 2. And then data ilog 0, 1. This one indicates access the first row of column B. And the previous one forgot something, data. Then if we do this, this indicates access column A. The fourth point for comparing the two codes is packages and libraries. In terms of packages and libraries, R is known for a wide range of packages, specifically tailored for statistics and data analysis. including dplyr for data manipulation, ggplot2 for visualization, and caret for machine learning. RS packages are mostly hosted on CRAN. That is where you find all the packages and libraries. For Python, it has robust libraries for data science and machine learning, such as pandas, which is used for data manipulation, matplotlib or seaborn, which are used for visualization basically, and also scikit-learn, which is used for machine learning. These libraries are broader in application and they are hosted in PyPL. The fifth point of comparison is function, definition, and structure. In this case, functions in R are defined using the function keyword. R functions often do not require explicit data types for arguments and are built with the data analysis in mind. For example, for R we can like add, then define this variable, function, then A of B. Then it return A plus B. Then if this function returns A plus B, then we give a value for A and B, and then the output will be the summation of the two. For Python, it uses the def keyword, not function, but it's def keyword for defining a function. And Python functions typically require explicit data types or use type hints, and are more general purpose. For example, in this code, we just def is the keyword that is used for defining a function. Then the add function A, B, then return A plus B. Then this function is similar to the above function for R, and their difference in terms of defining a function is R uses a function keyword, whereas Python uses def keyword for defining a function. The sixth difference could be on control structures. For controlling, R uses if, for, while, and repeat. For control structures, which are similar to Python's, but with some syntax differences. For example, for R, for I in 1 to 5, then we call print I. Then this one gives us values 1 to 5, and then when we print I, then it gives these values from range of 1 to 5. Whereas in Python, control structures are very similar, but emphasize indentation instead of like braces, the broken brackets, for defining blocks of code. For example, here we see for I in range 1 to 6, 1 to 6, print I. Then this is similar to the print, but they are a bit different in structure. Another point of difference for, or point for comparison, is vectorization and performance. In terms of this, R is vectorized by nature, allowing many operations to be performed element-wise on vectors without explicit loops, making it a bit concise and optimized for data analysis tasks. For example, just X, let's define this, C1 to 5, then Y is X times 2. Then in this case, what it tells us is that multiplies each element by 2. And in Python, in particular in pandas and NumPy, vectorization is supported, but is less intrinsic to the language itself. However, Python's general purpose nature makes it versatile for complex tasks as compared to R, and libraries like NumPy help optimize data operations. Let's see the following example. Import NumPy as np, then x equals np.array then 1 2 3 4 5, then y equals x times 2, and this is similar and multiplies each element by 2. The eighth point of comparison is object oriented versus function programming. In this case, R primarily, in terms of just for R, primarily a functional programming language with a function. It is a functional programming language with a functional approach to many tasks. However, R also supports object-oriented programming via S3, S4 classes, although these are less common in day-to-day data analysis. Python is object-oriented by design, and Python uses classes and objects extensively. And Python's object-oriented programming mode is more straightforward as compared to R, and is widely used than R. So that is the basic difference in terms of being object-oriented and functional programming. The ninth point for comparison is visualization. In terms of visualization in R is intuitive, especially with ggplot2, which provides a grammar of graphics approach that is popular for statistical data visualization. For example, like we have library which we import ggplot2. We import this library and then ggplot to ggplot sorry ggplot data AES x equals A, y equals B. Then we go here, class geom point. Yeah. Then this is ggplot is really very nice library for plotting different plots. Then for Python, it has matplotlib and seaborn for visualization, which offer more general plotting capabilities. They are more general compared to the visualization capabilities of ggplot2. Seaborn is also user-friendly for data visualization, while matplotlib allows for more granular control. For example, the following code gives us some insight. Import matplotlib dot pyplot as plt, and then plt dot scatter if we want to plot scattered plot. Then we have the data. Then we specify which column and data, and against column B, column A against column B. Then we specify plt dot show. Then it gives us a plot. The tense point for comparison is error handling. Error handling in R, error handling is done using try and try catch, often with a functional approach. For example, like result calls, try log plus silent equals true. Then if inherits result, try error. Print, finally print an error occurred. Yeah, it can be structured like this, the inner handling, and that's for R. And for Python, normally Python uses try and except for error handling. As you have seen, for R it is try and try catch, and here in Python we use try and except for error handling, fitting in with its object-oriented approach. For example, try result equals int A, um, except value error, then print an error occurred. Sorry. Yeah, generally, these are the main points that we can try to compare R and just these points that we use to compare R and Python. Generally, R is specialized for data analysis, statistical tasks, and visualization with syntax that supports these workflows very well. Whereas Python is a general purpose code with extensive libraries that make it versatile for data analysis, machine learning, and other applications. Yeah, its syntax is simpler and better suited for complex programming and software development. Otherwise, each language has strengths for specific tasks, and many data scientists and analysts find value in knowing both as they can complement each other very well. Generally, these are the differences between the two. Thank you for watching this video, and if you want to receive more videos on this and other issues, please don't forget to subscribe.